Hi guys. Hey, listen, I just wanted to cover something. I'm going to be sending you a pigtail in an alternate method for directly measuring uh, chassis current so that you can test items that are in use on patients. And so what I wanted to do is take a second to demonstrate the validity of the testing and then show you the test setup. So anyway, you guys have all seen this safety analyzer. It is a Dynatech Nevada 232D, and even though you're not using that currently, has the same features relative to opening the ground to get case leakage and that kind of thing. So we're going to use that. This is going to be our piece of medical equipment. Yes, it's a microwave, but the idea is the same. It's got a 3-prong outlet, it's got chassis leakage, etc. So it'll work pretty good. So in our standard configuration, what we normally do is we get our safety analyzer, we take the piece of medical equipment, unplug it, connect it here, fire up our safety analyzer. That powers the device. We've got normal, and obviously we go through a sequence. We start with checking the self-test. We measure the voltage between L1 and L2, L1 to ground, L2 to ground, and then we get to power cord resistance. Now right now it's showing infinite. It's because we don't have our safety cable hooked up. So we're going to hook that up. As soon as we do, we have a good current source here, and you're showing 33 ohms. The value that we always play with there is less than 50, and it is, so we're in good shape there. And anyway, what I wanted to show you is when you flip it to case leakage, you've got, normally you would open the ground and it gives you feedback on exactly how much is flowing from the case to the ground. In this case it's 148. Now we have a way of doing that without involving opening the ground, and the reason this is important, and you can back up and look at me. The reason this is important is because when a piece of equipment is in use, we can't do this safety test. So we have to do an exchange of the equipment. It's very disruptive to what's going on relative to the patient, etc. So came up with an alternate way to do that, and basically it comes down to a direct measurement using a clamp meter, which this one is made by Fluke. Is that good? And it resolves down to 0.000 mA, which is microamps, okay? So I'm going to demonstrate how this comes into play using our standard test setup. And you can see when we put it on the safety clamp that you've got 0.000 mA. As soon as you open the ground, okay, this jumps up to 148. This is at 143. It's within the margin of error. You know, this one I think is probably a better calibrated source. But anyway, there's a little bit of differential, and it's important that I show you that. So it's measuring 143. So the alternate method, I'm going to get rid of this guy completely. Plug our piece of medical equipment. Unplug the Dynatech Nevada. Remember that number, 143. 143 microamps of leakage. Pigtail, it's been put together. You've got the black-white ground is separated, and it's just a way for us to be able to use the clamp meter. So you plug this into the wall, same as you did your Dynatech Nevada. You plug your piece of medical equipment into it. Okay, you immediately have a good circuit. So this is powered up. And now what you're going to do is put the clamp meter that's sitting here at 0, and you're going to put it on, put the ground wire in the center of it, and lo and behold, 0.143 milliamps, which is 143 microamps, exactly what we were getting when we had it hooked up to the safety analyzer. So you can use this. We never lifted the ground. The patient was never in any kind of danger, and you've done the measurement that you need to do for your safety test. So that's it. End of story. Thanks for watching. I know that you'll find this useful and a big time saver, and obviously if you don't have to swap the equipment out and disrupt the patient and involve nursing, etc., etc., it's going to make your life a lot easier. So try it on some stuff, let me know what you think, and if it's a good process, we'll replicate it and get it out to the field.